Okay, this is the second video in the series on heat of reaction, heat exchange, temperature conversions, reaction energy, everything doing with introduction to thermochemistry. So what we have here is an example problem for the determination of the specific heat capacity of a sample, in this case a glass sample. Now, hopefully you have read through your class notes, looked in your textbook and so forth at a specific heat capacity or just the phrasing heat capacity. If you have, then you will remember that specific heat is the amount of heat energy required to raise the temperature of 1 gram of a substance by 1 degree. And that 1 degree can be measured either Celsius or Kelvin. So the specific heat or specific heat capacity is the amount of heat energy needed to raise 1 gram of a substance by 1 degree Kelvin or Celsius. Okay? So let's read this problem. Now, as you read this problem, I strongly recommend that as you come across a value, that you write that down and label the value. So that way you'll have all your variables, all your values listed, and I think that'll make it easier to organize with the formula and the calculation. So let's get started. A 4.0 gram sample of glass. Okay, so that is a mass measurement. So the mass of our glass sample is 4.0 grams. Okay, and it was heated from 274 Kelvin. Okay, so that's our initial temperature. I'm going to label that TI for temperature initial. 274 Kelvin. And it was heated to 314 Kelvin. So that is going to be our temperature final. Okay, while absorbing 32 joules of heat. Okay, heat is often labeled with the letter Q. Now, some textbooks will show it as a lowercase q. Other textbooks will have it as a capital Q. Okay, either way will work. Just get accustomed to seeing it both ways. And it's 32 joules here. Remember, joules is a common unit in chemistry to measure energy in. You'll often see joules or kilojoules, in units of 1,000 joules. Okay, so this is what we've got here. We've got a Q value, we've got two temperatures, an initial and final temperature, and we've got a mass of our sample. Now, hopefully you have reviewed your notes and so forth, and you have somewhere in your notes a formula with Q equals mc delta T. Now again, some textbooks will use ms delta T. So I often will call these equations mcat because that looks like CAT to me, or msat, SAT. Okay, so you see those two formulas. Now again, when you do calculations in chemistry, it is really helpful to label all of your values with their variables. Make sure you have your units. And then when you start the problem, write the formula. Then you can transfer these values over and it makes it more of a plug and chug calculation. So we've got mass is 4.0 grams. Okay. Now notice what we're solving for. We're solving for the specific heat of the glass sample. Well, the specific heat is labeled with the C, or some textbooks will have it as S. So we're hunting for that. Okay, I'm going to use the C. Now our delta T, what our delta T is the change in temperature. How did our temperature change in this process? Our temperature increased. That's a positive value. It increased by 40 Kelvin. Okay, I just took these two values and subtracted them, and remember, it increased, so That's why I'm putting positive 40. And our Q here is our heat value, our heat energy, and that is 32 joules. Now we can just solve this. 32 joules divided by 160. Now I'm bringing the units. It is important to have the units. Okay, I took 4, multiplied by 40, got 160, and I'm dividing out, just rearranging the formulas. So now the specific heat capacity, what we are hunting for, is equal to 32 divided by 160. So here on the calculator, it's hard for you to see. We go 32 divided by 160, and we get a 0.2 value. Okay, so we have C is equal to 0.2. I'm going to put another 0 because two significant figures. Do not forget your units. Joules over grams Kelvin. Okay, specific heat capacity has some unusual units. It's a derived unit of energy per mass and degree. Okay, so 0.20 joules per gram Kelvin. Okay, that tells us the amount of energy needed to raise 1 gram of this glass sample 1 degree Kelvin or Celsius. 0.20 joules per gram Kelvin. Okay, now let's try part B. Okay, part B says, how much will the sample gain when heated from 314 to 350 Kelvin? Okay, so how much heat? Okay, let me insert that. How much heat? So how much heat, how many joules will this sample gain when it's heated from 314 to 350 Kelvin? Okay, so again, let's start by writing our variables. We have an initial temperature of 314 Kelvin. We have a final temperature of 350 Kelvin. So our change in temperature is an increase, a positive 36 Kelvin. Okay, we need our mass. Our mass, it's this same sample, so it's going to be that 4.0 grams. Okay, now we just found our specific heat capacity, 0.20 joules per gram Kelvin. Okay, we just found that. So we've got all of those pieces of information. So let's set this up. Okay, we've got Q equals MC delta T. Again, write the formula. List your variables, list their values, and then this becomes a simpler problem. You're just merely plugging and chugging in values. Okay, we'll make it simpler for you. And 36 Kelvin, that's our change in temperature. Again, notice it is positive because we are increasing the temperature. Heat is being absorbed in this process. So we go 4.0 times 0.2 times 36, and we get a value of 28.8. Now this is joules. See, the grams canceled here, the kelvins canceled here, leaving us with joules. Now I need 2 sig figs on this, okay, because the 4.0, the 0.20, the change in temperature is also only 2 sig figs. So we will have this at 29 joules that this sample will absorb when raising the temperature from 314 to 350 Kelvin. Okay. Now this formula, this Q equals MCAT, okay, or MC delta T, or if you like the S, you can use it as well. Okay, lots of people like to rearrange it in the beginning of the formula. You can do so that M equals Q divided by C delta T, or you can have, delta T is equal to Q over MC. Okay, personally, I like to use the original formula, substitute in my values like we've done in these two examples, and then isolate. It makes it simpler for me. It's just my customary way of doing it. But if you want to rearrange the formula first, then substitute in your values, that's perfectly fine. You will still get the correct answer.